Hello everyone, I'm Antonis Andronikakis, Communications Manager at Refrain Food. Welcome to our Smart Droplets Project podcast series. Smart Droplets focuses on reducing pesticide and fertilizer use by integrating advanced technologies. It uses a holistic approach, combining various technologies, aiming to enhance crop care efficiency and environmental sustainability. Today, I'm happy to have with me Michiel Kallenberg from our esteemed Dutch partner, the Wageningen University. Michiel, welcome to our podcast series. We're eager to hear from you.
Hi, my name is Michiel Kallenberg. I work as a postdoc in the lab of artificial intelligence in Wageningen University, and I'm involved at the Smart Droplets project from the start.
Let's move on to our first question. For starters, we would like you to tell us in simple terms what digital twins are and how they are employed in the Smart Droplets project.
Okay, sure. Let's start with what digital twins are. So imagine having a virtual copy of something real, like a model that exists in the digital world, but behaves just like the real thing. So that's a digital twin. It's like having a video game character that mirrors a real life person or object that reacts and changes based on what's happening in the real world. So now in the Smart Droplet project we use digital twins of winter wheat crops and apple orchards. And these digital twins include all important details like plant health, soil conditions, weather data and more. And these digital twins are then constantly updated with real-time information from sensors and other data sources. And by analyzing this data and playing around with for example, different future scenarios, we can understand what the crops, which is winter wheat and apples, actually need at that very moment.
So a digital twin is like a video game that helps farmers anticipate what will happen in real world conditions, right? That sounds like an exciting idea. So let's move on to our next question. How does artificial intelligence actually enhance the capabilities of digital twins in the project? And maybe if you could give us some everyday examples of AI in action.
Okay. Let's first talk about how AI can take digital twins to the next level. So let's say you have a super detailed virtual model of your winter wheat field, which is our digital twin, and this model gathers information like soil conditions, weather patterns, and satellite imagery, which I named before. But having access to all that data, that doesn't help so much. So that's where AI comes in, and then you can think of AI as a kind of super smart assistant to your digital twin. So it analyzes all this data and then make practical recommendations for your farm. For example, if the digital twin detects a nutrient deficiency, then the AI algorithm exactly calculates how much fertilizer each part of the field needs. It can be seen as a personalized fertilizer plan for every corner of your farm. So that's basically in a nutshell what it does. So the AI analyzes this data and then comes with an advice.
Mm-hmm. It seems that AI can play a crucial role in helping farmers manage their crops, but we'll talk about it later. What were the key steps in creating the AI and digital twins for Smart Droplets, and in your opinion, what makes them special?
Okay. So basically the digital twin the digital twin is basically a representation of the crops, and this digital twin is then grounded in decades of research and development. In this case, at our university, where crop models are being used that are the backbones of our digital twins. But then on the other hand, we have the AI system that empowers the digital twins. And this is based on reinforcement learning. So this reinforcement learning algorithm tries to teach an agent through trial and error to develop a plan for how to fertilize and how to apply pesticide applications based on simulations that it does using this digital twin of crop model for a different series of scenarios that are based on weather patterns, soil conditions, and crop health. And the AI agent then learns from these simulations and figure out optimal strategies for fertilization and pesticide application based on the outcomes that are observed in our virtual environment that is based on the digital twin. So that's in a nutshell how it works.
Mm-hmm. From your answer, I understand that a lot of work was put in training the AI algorithm. I think that this is something that deserves credit. Miguel, I'd like to thank you for sharing all these great insights, and it was a pleasure talking with you.
Okay, thanks a lot. Yeah.
So for the second part of our episode, I'd like to welcome Hilmi Baya, also from the Wageningen University. We will focus more on the role of AI in farming practices. But before we proceed, Hilmi, I'll let you introduce yourself.
Thank you, Antonis. So my name is Hilmi. I'm officially a PhD candidate in Wageningen University. And my main role in the Smart Droplets project is working on Work Package 3, which is the digital twin and the AI recommender system.
Let's start by telling us how will digital twins and AI change the way farmers work, and what are the biggest benefits a farmer can expect?
Okay, how farmers work. So in this project, the digital twins are equipped with AI that can continuously monitor and analyze farm conditions in real life, and they generate alerts and associate recommendations. And it notifies farmers when specific actions are needed, such as applying fertilizer or spraying pesticide. And this approach, of course, saves time and ensures interventions are timely and precise. And also, precision is actually another major advantage. So, traditional farming, often they apply inputs uniformly across the fields, and this, depending on the dynamics of the field, this can lead to inefficiencies and unnecessary resource use. But then with digital twins and AI, farmers can apply inputs more selectively and precisely. So for instance, using these sensors and AI-driven analysis, we can determine which sections of the field need certain amount of pesticide treatment based on the pest levels, and we can minimize chemical use with this, and we can also maximize its effectiveness. And also with fertilizer application, we can tailor specific soil nutrient needs and crop growth stages, optimizing yield and also reducing environmental impact from fertilizing.
Now I think that we have a clearer view of what digital twins can do for the farmers. I think that a very important aspect is that farmers can also save inputs besides the environmental benefit and the benefit of crop care efficiency. But can you share maybe a success story or an example where these technologies have actually made the real difference in farming?
One example that comes to my mind right away in the domain of agriculture is in greenhouses. So in more controlled environments, such as of course greenhouses and more similar environments, the usage of digital twins in combination with reinforcement learning has shown some promising results. So an AI system, this reinforcement learning agent, then can automatically control lighting and temperature. And some colleagues in Wageningen Research here have tried this with promising results. And now it's up to us, Wageningen University, in the Smart Droplets project, to try test this similar technology in open farming or arable farming.
It sounds very interesting. Thank you for this great example. Moving towards the end of our conversation, I'd like to ask you a more general question. I mean, what exciting developments or new features do you see coming for digital twins and for AI in agriculture?
So, what comes to mind is exciting developments. I think there are three main ones that are enabling these exciting developments. So, first, there's the presence of the advanced sensors, and remote sensing technologies, which revolutionize data collection in farming. So they enabled farmers with detailed insights into crop characteristics and like soil moisture, nutrient levels, plant health, and then also it enables more precise monitoring and management. And second, there's the machine learning algorithms that worldwide are being researched very, very deeply. So these algorithms are becoming increasingly and sophisticated and have processed vast amounts of data from digital twins. And they translate these data into actionable plans. And this helps farmers optimize decisions such as irrigation timing, fertilizer application, or pest management. And of course, with increasing accuracy. And lastly, there's the evolution of machinery in agriculture, which transforms farming operations. So autonomous driving technology, for instance, allows precise and efficient field operations, and autonomous vehicles equipped with these AI-driven systems can navigate fields autonomously and applying inputs and performing tasks with efficiency that was previously not attainable.
Many exciting and great developments are in store in the near future. Hilmi, I want to thank you for being with us and explaining how AI and digital twins can make a real difference in crop care practices.
Thank you.
And to our viewers, thank you for joining us today. Don't forget to follow our social media channels and of course our YouTube channel. Stay smart.